Hey y'all, welcome back. On tonight's homework, we're still working with the first derivative test, which is a tool that we can use to help determine whether or not a function is increasing or decreasing on certain intervals, and also helps us find the relative extrema. So to use that first derivative test, we need to first find the first derivative. So number one says, let f be a function given by this cubic equation here. On which of the following intervals is the function increasing? So for the function to be increasing, the derivative has to be positive. So let's actually find the derivative here. We can differentiate using the power rule. So 300 minus 3x squared. And then we need to find critical points so that we can find the partitions of our number line and make our sign chart. So I'm going to set my derivative equal to 0, divide everything by 3, add x squared to both sides, and then finally take the square root of both sides, which gives me x is either plus or minus 10. So on my sign chart for f prime, I'm going to label negative 10 and 10. And now I'm going to test values back into the function to see if, and by into the function, I mean the derivative here, right here. So I'm going to be testing values into here to see if the derivative is positive or negative. So if I plug in a number like, let's say, negative 11 or negative 100, let's go crazy. So negative 100, if I plug that in here, negative 100 squared is going to be like, what is that, 10,000 or something? So we have 300 minus 30,000. That's going to be negative. And then if I plug in a number like 0, I get 300 minus 0, which is positive. And then finally, if I plug in a number like 100, I'm going to have the same output as if I plugged in negative 100. So in this interval, it'll be negative. So the only interval for where the function is increasing is in between negative 10 and 10. So our answer is B. And you might notice that we have got brackets here instead of parentheses. You could use either one. It's not actually going to be, I kind of like having the parentheses over the brackets here because at 10 and negative 10, it's not increasing or decreasing. But I think on the AP test, they're comfortable with using either one. So don't let that throw you off. As far as our justification, we're going to say that on the... Sorry about that. As far as our justification, we're going to say that we know that the function is increasing because on that interval, the derivative is positive. Number two, we're given another cubic function here. And it says, for what values of x does it have a relative maximum? So we need to find the derivative and set it equal to 0 to find those critical points. We can factor out x, actually 3x. You know what? Let's actually divide everything by 3. Let's make this even easier. Then we can factor out an x as a GCF. And that's going to lead us to having two critical values, one at x equals 0 and one at x equals 2. So we need to find which one is a maximum, if any. And the maximums occur, we have a relative maximum. The first derivative test says that this occurs whenever the slope goes from positive to negative. Just imagine what a maximum looks like, right? You got a positive slope followed by a negative slope. So that's what we're going to be looking for in the sign chart. If I plug in a negative number for this first interval, I'm going to have a negative times a negative is positive. If I plug in 1, I have a positive times a negative, which is negative. And if I plug in a number like 3, I'm going to get a positive times a positive, which is positive. So the slope is positive, followed by a negative slope. And then at 2, I've got a negative slope followed by a positive slope. So we have a local maximum at... Oh, excuse the bells. We've got a local maximum at x equals 0. So we have a max at x equals 0. Okay, and we know that because the slope, f prime, went from being positive to negative. Now, part B asks us to find the value of the maximum. So we know where the maximum is, but what are the actual coordinates of that point? And so to find the y coordinate, we're just going to substitute in 0, which is our x coordinate, into the original function f. So this should be pretty easy. It's just going to be 0 minus 0 is 0. So f of 0 is 0. So we have the value of the maximum is 0. Okay, so we're finding the y coordinate. The actual maximum is at 0, 0. So I just want to be real clear that when we're finding the value, we are finding the y coordinate. Number 3 says determine the intervals for which this function's decreasing. Now here they're giving us f prime rather than f. So we already have the derivative. We just need to find the critical points by setting this equal to 0. This is a polynomial, so we don't have to worry about it being undefined. And we're going to get 2 critical values. We're going to have one at -2, and we're going to have one at 3. I'm going to put both of those critical values on my number line. Start testing this out. If I plug in, let's see, -5, I'm going to have, now this x minus 3 to the 4th power here. This is always going to be positive because we're raising it to an even power. So I can just safely ignore that and really just focus on this x plus 2. And so that's what's going to determine whether or not the sign is positive or negative. So at any rate, if we plug in something like -10, this is going to be negative. So the overall slope will be negative. If we plug in a number like 0, 0 plus 2 is positive. So we are positive between -2 and 3. And then finally, if we plug in a number like 10, it's still going to be positive. So there's only one interval where it's decreasing, and that's from -infinity to -2. Number 4 says let f be a function given by another cubic. I'm getting a little cubic happy here, where k is a constant. Find the value of k for which f has 11 as its relative minimum value. So first let's find where the minimum is. What's the x value of the minimum? To do that, we're going to find the derivative. And when I use the power rule to do this, what you're going to notice here is that the k goes away, because k is a constant. So the derivative of any constant is just 0. So here's my derivative. Set it equal to 0, and we're going to solve this. Now, this is a pretty rare case where the leading coefficient is not 1. So just be careful when you're factoring this. The factors are going to be 3x minus 1 and x minus 3. This is going to be pretty uncommon for that leading coefficient to not be 1, but here's a case where you just kind of have to deal with it. So that gives me 2 critical values, 1 at 1/3 and then 1 at 3. And if I plug in a number like 0, I'm going to get a negative times a negative, which is positive. So in this first interval, I know the slope is positive. If I plug in a number like 1, I'm going to get a positive times a negative, which is negative. And if I plug in a number like 10, I get a positive times a positive, which is positive. So a minimum value is where you have the slope changing from negative to positive. So that's happening here at 3. So we've got a minimum at x equals 3 because the slope, or f prime, well, I'm running out of space here. Let me just maybe back this up and put on the next line. Because f prime went from negative to positive. So we know where the minimum is, but what we're looking for is the value of k if the value of the minimum, or in other words, the y coordinate, is 11. So what we need to do is actually go back to the original function, and we're interested in, what is k if x is 3, which is what we just found, and y is 11. So we'll plug all that stuff in here, and hopefully the arithmetic won't be too bad. I'm a little nervous here, to be honest with you, but let's go ahead and do it. 11 equals 3 cubed minus 5 times 3 squared plus 3 times 3 plus k. So 3 cubed, that's 3 times 3 is 9, times 3 is 27, minus 5 times 9 is 45, plus 9 plus k. Let's see, 27 plus 9 is going to be 36, and 36 minus 45 would be the opposite of 45 minus 36, so that's going to be negative 9. So we got 11 equals negative 9 plus k, and if I add 9 to both sides, I'm going to get 20 equals k. And there's your answer for number 4. Number 5 says g is a differentiable function such that g is negative for all real numbers x, and the derivative of f is this expression here. Determine the value of x for which the graph has a relative maximum. So a relative maximum, again, occurs when f prime goes from being positive to negative. All right, so if f prime, where are we? Okay, so yeah, if f prime is x squared minus 9 times g, then if I set that equal to 0, then either we're going to get x squared minus 9 equals 0, or g of x equals 0. So x squared minus 9, we can solve that by adding 9 to both sides and then taking the square root, and we get plus or minus 3. Okay, now here's the thing. It says g of x is negative for all real numbers x. So g of x equaling 0 never happens, right? Because it's negative for all x values. So the only two critical values here are going to be plus or minus 3. So when I draw my little sign chart here for f prime, I'm going to put negative 3 and 3 and start going to work with testing the different intervals. If I plug in a number like, I don't know, negative 5, I've got negative 5 squared is 25 minus 9 is positive. G is always negative. And that is according to the problem. I'm not just making that up. That's just how the problem's set up. So we will have a positive times a negative, which is negative. Then if I plug in a number like 0, I get a negative times a negative, which is positive. And finally, if I plug in a number like 10, I'm going to get a positive times a negative, which is negative. So we're looking for where is there a relative maximum. Just like we said, this is going to happen when f prime goes from positive to negative, and that is happening right here at 3. So we've got a relative minimum. Oh, I'm sorry, maximum, not minimum, at x equals 3 because f prime went from being positive to negative. Number 6, we're given the graph of f prime, and we want to know where does the original function have a local maximum. So again, a local maximum is where f prime goes from being positive to negative. It's where the slope of the original function changes from increasing to decreasing. That's how we know we have that maximum. So that's only happening in one place. If I look at this graph, and this is the graph of f prime, this interval from negative 3 to 1 is positive. So if I create a number line here like I've been doing for all the other problems, in between, actually we don't even really need the 0 there, in between negative 3 and 1, the derivative is positive. And then for these other intervals, the derivative is negative because it's below the x-axis. So in order for us to have a local maximum, f prime has got to be going from positive to negative. So we can see that that is happening at 1. There we go. So yeah, we've got a local maximum at x equals 1 because f prime goes from being positive to negative. Oh, there's my just. Didn't even look at the fact that this was a multiple choice question. Okay, so yeah, C's are going to be our answer. I just got so wrapped up in solving the problem that I didn't even notice it was multiple choice. Our justification is because f prime went from being positive to negative. All right, last page here, number 7, another graph of the derivative here. So I think I'm just going to jump straight to this number line chart. I think it'll help us, whatever the question happens to end up being. And I'm going to put, let's see, -9, really all my key points here. -8, -2, 2, 8, and 9. All right, so looking at this graph, we can see that the derivative, which is what this is the graph of, is positive in these green intervals where I'm highlighting, and negative underneath the x-axis. So for my number line chart, I know the slope is going to be positive for f of x between -9 and -8, between -2 and 8. And the derivative is going to be negative between -8 and -2, and finally 8 and 9. So I haven't even really seen what the question is here, but I'm just kind of laying this out so that maybe answering the questions will be a little easier. Because the slope's going from positive to negative, I know I have a local max at -8. It's going from negative to positive, so I know I have a minimum at -2. At 2, we have a positive slope followed by another positive slope. So this will be neither. This is still a critical point, but it does not result in an extreme value. And then finally at 8, we're going from positive to negative. So here we have another max. So let's see exactly what this thing's going to be asking. A says determine the critical values for f of x. So critical values are going to be any x value that makes the derivative equal to 0 or undefined. Now, we don't really need to worry about the endpoints here. We're just going to be looking at really these x-intercepts where the derivative is 0. And so that's going to be at -8, at -2, at 2, and at 8. So we've already classified each of these, so this won't take very long, but I want to make sure I have a justification for each one. So we know that x equals -8 is a max because f prime went from positive to negative. We know at -2, we have a minimum for the opposite reasoning. F prime's going from negative to positive. X equals 2 is neither a max or a min because the sign of f prime didn't change. And finally, at 8, we're going to have a maximum for the same reason that we have a maximum at -8. F prime went from positive to negative. B says determine the intervals on which it's increasing and explain how you know. And then finally, C is asking for the decreasing intervals. So the increasing intervals will be anywhere where the derivative is positive. So f prime is positive. The decreasing intervals are going to occur anytime the derivative is negative. So it's increasing on negative 9 to negative 8, negative 2 to 8. And we know this is true because f prime is positive. And let me zoom out so we can actually see the rest of this. For these intervals on which it's decreasing, that's going to be where the slope is negative. So we can see that's happening between negative 8 and negative 2, and it's also happening between 8 and 9. And we know that these are decreasing intervals because the derivative is negative. Letter D says if f of 6 is negative 2, determine the equation of the line tangent to f of x at x equals 6. So we're going to set this up just like how throughout the year we've been setting up all these write the equation kind of problems, where we have a point, we got a slope, and then we want to write the equation in the form y minus y1 equals m times x minus x1. So the point's given to us. It's 6, negative 2. We just have to find the slope where x is 6. Let's scroll back up and see what's going on when x is 6. Now, when x is 6 here, we can see that the derivative's value is 3. So that means the slope of f, right, since this is f prime, that is the slope of f is 3 when x is 6. So the slope is 3, and now we can write our equation. Y plus 2 equals 3 times x minus 6. E will be worked really the exact same way. We just have a different point here. Our point is 4 comma negative 8. Our slope is to be determined. We're still going to write this in point slope form. So let's find the slope when x is 4. Go back up here. X is 4. Looks like the slope is 2. So once we have that slope, we can write our equation. Y plus 8 equals 2 times, x minus 4. Our last question of the day, for what values of x will the second derivative be equal to 0? Okay, so for the second derivative to be equal to 0, that means that the slope of f prime must be 0. In other words, we're looking for where f prime has a horizontal tangent line. So let's look back at that graph and see where we can find horizontal tangent lines. They're going to exist really everywhere where we see relative maxima and minima. Let's clean this up a little bit. So we can see that we've got a relative minimum at x equals negative 5. We've got a horizontal tangent line. We also have one at x equals 0, at x equals 2, and at x equals 6. So let's see if I can remember this. Well, I'll just go back here and write them down one at a time. So x equals negative 5, 0, 2, and there was one more at 6. So on all these, the derivative of the derivative would be 0. And that wraps it up for tonight's homework. As always, please reach out if you have any questions. Thanks for watching, and y'all have a great day.